Perhaps another named function that would be useful is the ability to add random noise to a vector of values, as we are doing right here in order to create our artificial data based on a known standard deviation. So how would we go about writing a function like that? Well, it's going to be the same idea. We'll call this one add normal error. We define our function. We need to know what the arguments for this function are going to be. Well, a couple of things we know we're going to need are the vector of values that we want to add the noise to, as well as, yeah, we want to be able to change the standard deviation, right? Someone should be able to give whatever standard deviation they want to that error. Now this vector that we're getting is not necessarily an f of x. It could be any vector. So we're abstracting this to be useful for any vector. So let's call the vector v, and let's just call our standard deviation argument sd. So we're going to need a block of code. And again, because this math is doing approximately what we want, we can copy and paste this to help us get things started up here. When I'm extracting something, it's frequently doing exactly this. I copy and pasting a block of code and then changing the variables so that it's working abstractly within the function that I'm defining. Usually I've already written the function. I'm just copying and pasting blocks of code into it to get it to do what I need it to do. Okay, so in this case, I've renamed f of x to v, or I'm thinking of that f of x as a vector, so instead of f of x, that should be v. And instead of 2 being called here hard-coded, I want to give the person who's calling this function the ability to change that. So I have this argument sd, so what I should pass to sd of the rnorm function is the sd that's passed to me from the user. Now this is where I can imagine that, oh, I can add some features here, or some functionalities here that I don't really need right now, but may be useful in the future. I can recognize that, well, what if I do at some point want to add some sort of bias to my error? And that bias represented by some mean of value that I want to be away from the vector that is provided. Well, this is where having default values for arguments can come in really handy in R. I can say that there's an argument to this function that I'm going to call mean that allows people to set it, but I'm going to put an equal sign here and give it a default value of 0. And then, instead of hard coding a 0 in my function code, I'm going to say, well, take on whatever value this argument is. So this is the way in R, if the user doesn't provide the argument mean, then the mean is automatically going to be a 0. But this still gives the user the ability to change the mean to something other than 0 if that's what they want the mean of their error to be. So sometimes when you're writing a function, especially if it's this easy, you'll add a feature like that, even though you're not really using it yet, because you're just making your function a little bit more abstract. You're making it so the function can do more things based on the arguments that you give it, without having to write specialized code to do that. Okay, so I've written my function. Now I can make use of that function down here where I'm doing that work. So in place of this code, I'm going to do add normal error. And recall the arguments that I'm going to need for add normal error are the vector. What do I send that vector of values? Well, that's going to be my f of x. My standard deviation, and a mean if I want it. But in this case, I want my mean to be 0, so I don't have to provide that argument. So down here, I can just say v equals f of x and sd equals 2. So assuming I don't have any typos, I should be able to run this code and it still does exactly what it did before, but now I have this bit of code abstracted in this function that lets me add normal error to any vector that I provide, or that I wish to add error to. And this particular add normal error lets me change the mean if I want to create some mean bias in that error as well.